Hi, my name is Mitchell Rosati. I'm a sophomore at Western Carolina University in the electrical engineering program.
Hello, my name is Alex Judson, and I am also a sophomore electrical engineering major here at Western Carolina. So, what we've done in the past semester is built an honors project, which is a hydroelectric generator, effectively, that is meant to be placed in some sort of river or creek, perhaps on some sort of camping trip, that type of thing, where it can produce electricity that we are demonstrating with our LED.
The idea for this project was hoping to have a portable system that you could put in a low head stream and produce power and maybe charge a phone or something. This is just a proof of concept of that idea. We went through a couple of design iterations, in some of them with two separate water wheels, but we ended up deciding on a system that uses two bases to funnel water into a channel with the wheel in the middle. And when we started this project, we divided up the system into the internal and the external elements, and we worked in conjunction on the whole base and I guess chassis frame, whatever. I took the external elements, the water wheel and the axle rod and bearings, and Alex designed the internal elements. So
I designed the internal parts, including the gear system on the inside, the majority of the generator housing, of which, as Mitchell was saying, a lot of this external piece was a collaborative effort, naturally. And making all of that internal system here and all of the wiring work together so that it could produce electricity at the end of the day.
The function of my piece of the project was to measure the actual produced voltage of the generator while it was functioning. So we took some measurements across different resistor values and figured that although the generator we bought is a 3-volt DC generator, roughly with our situation, we were only able to produce an average of probably less than 1 volt. And you really have to get it moving fast in order to make it light something or produce a usable voltage. So whenever we tested it in the water, or we just put it in a sink, it didn't really the water wheel barely even moved.
Yeah.
So you really have to get a lot of power in order to start spinning these things.
You really have to get a lot of water flow in order to get these to spin at a rate that would actually light up the LED to a decent level. I suppose that in itself was kind of our failure at the end of the day, that we had designed it, but it wasn't unable to really produce a whole lot of electricity without us manually flicking it in such a way that we could get it to show up in an LED. Now, that said, we were able to get a video of the LED actually lighting up. So we're going to go ahead and pop over to that video, in which you'll just be able to watch and see the LED flicker a couple different times. Okay, this is going to be test 2 of we're going to be showing the LED lighting up in a more efficient manner. If you go ahead and spin the generator. Now, as you can see, the LED is lighting up when it is spinning at a certain speed. We were unable to...
The flow of the water does not spin it that fast because you really need a lot of speed to get it going.
And that type of speed was just something we couldn't necessarily get done inside of a regular sink, and would likely require that we have some sort of water falling scenario to test this optimally. Alright, so as you should have seen in the demonstration video that we panned over to, the LED was in fact lighting up when we were flicking it with enough force to actually get the motor spinning fast enough for it to light up. Now, naturally, it didn't light up for very long because sustaining that sort of speed is just not very possible when you're doing this manually. And without a strong enough water flow, we weren't able to make that happen. Now, naturally, part of that failure, I believe, was really inside of my own components. Doing the gear mechanism could have very well added a little bit more than necessary kind of torque inside of that ratio. That wasn't allowing this to spin as quickly as we could have had it. Could have also made it more difficult to spin in general, and that could very well be one of the many problems.
Kind of the nature of producing 3D printed parts out of plastic, it makes it challenging to acquire enough mechanical advantage to actually spin the generator fast enough. And as much as that's a failure, it's also a learning opportunity in the sense that it's a lot harder to produce power than people might anticipate.
That most definitely is.
And harder than I anticipated it was going to be.
And harder than I was, too.
Okay.
So, alrighty. Well, that will conclude our presentation video. And
Honors Project 2023.
alright.